With the use of training, there are many adaptations that the body can make as long as the training follows the sport and fit principles. For example, for progression to be made, the training has to be a number of things, like specific, for example. This, along with progressively overloading the training, and much more, is key, as it allows the different parts of the body to slowly improve as training is applied. Specificity is key, as the training needs to be definitive to the goals you want to reach. This is because different sports require different needs, and therefore different goals would be set for different training between each person, as a marathon runner may want to improve his/her aerobic endurance, whereas a 400-meter runner would want to increase their power, as it is a much shorter race where a quick burst of energy are needed, and there is a much lower time duration. As stated, due to these different requirements, training has to be adjusted to become specific to the sport, so that the goals are reached. This can be seen clearly in the two different types of weightlifting, from trying to improve your muscular endurance to training to improve your power of your 1 rep max. For example, when training for your muscular endurance, you want to be working at using around 65% of your 1 rep max, with 3 to 4 sets of 10 to 12 reps. On the other hand, if you're trying to improve power, you'd want to work at a much higher percentage of maybe 85% for a reduced 3 to 5 reps, as you want to be working anaerobically. This can also be seen with running, as a marathon runner would perhaps use continuous training for long periods of time at a low intensity, so that they are working aerobically and at about 75% of their max heart rate, whereas a sprinter may use HIIT training so that there are rest periods and you are working at 80 to 90% of your max heart rate anaerobically. Training is vital for sports performers working in the field of anaerobic events for a number of reasons, as it can allow the athlete to perform at a high level for a longer period of time, produce more power than the muscles, and reach their peak power faster. This is key for many sports, as a lot of the anaerobic aspect is the primary system used, like during a 100 to 400 meter sprint, for example. As well as the sports that involve small parts of anaerobic fitness, such as football, for example, where power is required in kicks and sprints. The athletes in these events, and many more, can all be substantially improved through the right training that would allow them to become faster, stronger, and more powerful for a longer period of time, through adaptations, and therefore reach a higher level in their chosen sport as a sprinter that can produce a higher force for a longer period of time than competitors would likely win the race. These improvements can all be seen during multiple tests, like the Wingate, where the data allows you to visualize the adaptations made in different systems of the body. Training for anaerobic performance also massively benefits your health, which would allow your body to become more adept to fight diseases or conditions, as well as becoming more able and free to move as you reach an older age than you would have been. Anaerobic training benefits both the cardiovascular system and the respiratory system the least out of the multiple systems, as they are more adapt to aerobic training, which can be talked about later. Despite this, HIIT training, which is a form of anaerobic training, as it is high intensity where the athlete works maximally for a short period of time, can lead to cardiovascular and respiratory adaptation. However, not to the level that aerobic training can, so this will be talked about later. Unlike the cardiovascular and respiratory systems, the neuromuscular system adapts in a number of ways to training anaerobically, and therefore sports performance can be improved. For example, one adaptation that is made is to do with the neural pathways, as impulses can travel quicker. These changes occur due to muscle memory known as neuromuscular facilitation, which is built up and improved with each training. This allows the impulse to be sent down the pathway almost automatically, meaning that the movements happen quicker. Furthermore, as the pathways become used to transmitting impulses to the muscles, they become more efficient, further increasing the speed in which impulses can travel down. This, along with more sensitive proprioceptors, are also key with increasing reaction time, as the movement needed can be detected by the proprioceptors and therefore then sent down the neural pathways to the muscle at a quicker speed, allowing the contraction to occur faster. Due to anaerobic training, more motor units can also be recruited, likely fast fatiguing or fast resistant units, and improved to increase their ability to summit with strength and power training. This allows a higher force to be created from the contraction, increasing power in almost any sport. Similarly, it is likely the percentage of type 1 fibers will decrease and type 2 fibers will increase, as they have a faster twitch, meaning that they contract quicker, which is important for anaerobic events, and fatigue is not a factor as much. These fibres grow when more fibres are recruited due to hypertrophy, as there is an increase in muscle cells and therefore the strength increases. Overall, the neuromuscular adaptations are hugely beneficial for sport events like a sprint, for example, as it increases both reaction time and force generation, which are both key parts of the sport. This is because the sprinter will initially be able to react quicker to the gunshot, perhaps giving them an early advantage, which can be held with the increased force that is being generated in their leg muscles, giving them more speed and power. Similarly to the neuromuscular adaptations, the energy system also undergoes many improvements as it is trained for anaerobic events. Firstly, as it is anaerobic events we are training for, we can interpret that the PC system and the glycolytic system are the two being used, as they involve no oxygen. As opposed to the glycolytic system, there is little enzymatic change in the PC system. However, some small improvements are made. For example, there is a small increase in enzymes which help break down the PC. There is also more ATP and PC stored in the muscle as the body begins to understand that it is needed, so there is an increased capacity to create ATP. Overall, this allows us to reach a higher peak power and also reach it sooner, as strength is increased as a result of this, which can be seen in the Wingate test. For an example, in the graph, the peak power is 682 watts, and it's the highest point on the graph from the Wingate test. However, after training, this could be raised along with the time taken to reach this point, which is initially 4.391 seconds, as there is already high levels of ATP and PC stored in the muscle ready to create energy and strength, meaning it can be reached quicker and a higher peak power. Another improvement in the graph could also be seen with the increased anaerobic training and involves the ability to sustain a high level of power throughout the test. As this involves points at the time after 10 seconds, we can focus on the glycolytic system here, as it begins to become dominant at approximately the 10-second mark. It can be seen that in the graph that once the student reaches their peak power, the power begins to gradually decrease as they are fatiguing. It is likely this is due to the lactate that is being produced as a byproduct of this system. The muscle begins to fatigue and ultimately, as a byproduct of this system, the muscle begins to fatigue and ultimately produce a lower power. As can be seen in the OBLA graph, as the workload increases, the lactate begins to increase. However, due to training, this can be buffered, causing the lactate to begin to be produced later in the exercise, meaning the athlete can work for a longer period of time at a higher intensity with little fatigue, as the lactate graph is shifted to the right. Your body can also become more tolerant to lactate, meaning it has less of a fatiguing effect if it does get to the point where lactic acid is being produced, despite it being delayed. In addition to this, the glycolytic system also gains more anaerobic enzymes with the training, meaning the glucose can be broken down faster and more efficiently. Finally, training anaerobically can also improve your basal metabolic rate, meaning you burn calories and therefore have a stronger engine to compete in activities/exercises. These are all extremely important improvements for a 400-meter athlete, for example, as they would initially be able to reach their peak power/speed faster, which would also be higher due to training, as well as being able to sustain it throughout the whole of the race with little fatigue, as the lactate threshold has been buffered, giving them a high chance of winning the race.